a solar probe. None of them ever actually made it as far as we have right now. The game changer for this mission came when somebody said, well, hey, instead of using RTGs and going out to Jupiter, what about if we stayed in the ecliptic plane, used solar panels, and flew past Venus? That gentleman was Dr. Andrew Danzler. We lost Andy way too early, far too early for him to be able to see this mission come to fruition. However, the launch vehicle is dedicated to Andy, and so and his family are here. And so when the vehicle goes up today, it will carry Andy with us into the sky. And so I'd like to recognize the Danzler family who are here. Let me tell you about this amazing mission that is going to do the science of Gene Parker with the design of Andrew Danzler. If we can run the first movie, please. So the science of Parker Solar Probe, what are we going to do? Why are we going to the corona? What makes it so important? We need to get into the corona so that we can answer questions that have basically puzzled scientists for decades and decades and decades. Number one, why is the coronal material? Why is that? You probably all saw a total solar eclipse last year. Why is that material that you see 300 times hotter than the surface of the sun? Why indeed, where we see this incredible heat, do we suddenly see the plasma energized so much that it can break away from the pull of the star and bathe all of the planets? And that, of course, is what Gene Parker predicted in his 1958 paper, that this atmosphere would be continually expanding. And so they are the two mysteries that we really need to do. We've done so much, particularly with NASA missions, with observations, looking at the sun in all kinds of different ways. We've had spacecraft in the solar wind as close in as Mercury. But we need to go 7 times closer than that to really unlock the mysteries of the corona. I'd have the next movie, please, Tiffany. And so how are we going to do it? This is a site you should all recognize. You can see it outside. This is a Delta IV Heavy, not the same one. This one's going to launch right now. And up it goes, slowly. The Delta IV moves slowly. And so up it goes into space, and you'll see the fairing open, and solar probe will be out in the atmosphere for the first time. Shortly after that, the second stage, our cryogenic second stage, will fire and then separate. And then you'll notice what makes our mission a little unusual. We have a third stage, even on top of that huge Delta IV Heavy, and that provides us 55% of our launch energy, because we need a lot of energy. First thing we do when we are on orbit is put out the solar panels, so we are getting our needed power. We deploy the instruments. There is the fields magnetometer and the electric fields provided by University of California, Berkeley. And we move in, just very, very busy for us. Just 8 weeks after launch, we will encounter the planet Venus for the first time. We use Venus to give us a gravity assist. You may wonder why we're launching at night. No, it's not because it's easier and because the sun is dark or anything. It's because we need Venus to be in exactly in the right place. I had that question on social media today. And we will then go in. We use Venus to give us like a little handbrake turn. It turns that orbit in and focuses it in towards the sun. We will repeat that 24 times. We will fly past planet Venus another 6 times, and each time we do, we will walk that orbit closer and closer until we are closer than anything, about 7 times closer at 3.83 million miles above the solar surface. So we are hotter, we are faster, we are closer. We're the coolest, hottest mission under the sun. Next slide, please. And so how did we build it? And some of you will recognize family members here. So here we are putting together the structure. You'll notice solar probe is very small. She has to be very light so that we can throw her away from the planet really, really fast so she can lose all of the influence of the Earth. There you see the flight harness coming in. And now this was the day that solar probe finally looked like solar probe. We put the top deck on. And that holds the radiators that we use to cool the solar panels, and also, most importantly, our heat shield. And you see our heat shield being built here. It is a sandwich structure. It's made of carbon-carbon composite, a little bit like a graphite epoxy that you have in your golf clubs. There you see Betsy prowling around. She never lets the heat shield out of her sight. We put the heat shield together. Now you're seeing the spacecraft vibrating. That is a terrible sight for anyone who loves a spacecraft to watch it vibrate. We then took it down the road from the Applied Physics Lab where it was built, and we put it inside the thermal vac chamber at NASA's Goddard Space Flight Center, where we basically simulate space, taking it all the way hot and all the way cold, just like she will have to see on orbit, and really kind of stress the system to make sure if it's going to break in that chamber where we can fix it. After a successful thermal vac, we then put her in her travel crate, and we had a very nice ride down to Florida on a C-17, courtesy of the US Air Force. And here we are unloading her in Titusville, about 8 miles up the road. From there, she was delivered to Astrotech Space Operations, where she did all of her final preparations for launch. So here you see us putting the solar panels on, and they're in their protective case right now. Our solar cells, we actually use solar power to power the spacecraft. That may sound like a no-brainer, we're going to the sun, except that solar panels do not like to get hot. And so a big technology development for us was how to keep those cool. And we actually flow water through between each of the cells to keep them cool on orbit. There's a laser test to make sure that each one of those cells is working correctly. And now the moment that all of us on the mission were really, really waiting for was the day that Solar Probe got her crown. Oh, no, sorry. Wrong cue. So there, a lot of you would have sent your name into Go on the Sun. 1.1 million of you did that, and there is the chip. That is the chip that dedicates the spacecraft and the mission to Gene Parker, and also has his paper and some photographs on it. And here we are with Solar Probe getting her crown. The heat shield was traveled separately down to Florida and met the spacecraft there. And so now you see Parker Solar Probe in her full flight configuration. The next thing we did was put her on top of our third stage provided by Northrop Grumman, and you see that being installed there. And then the final shot, my favorite shot, probably the one most posted on Facebook in the last week by the team, is our beautiful spacecraft in her very blingy, tricked out 65-foot fairing. And when we saw the sight of the fairing, my project manager and dear friend, Andy Dreisman, said, "Is it too late to get a bigger spacecraft?" And so it really does take a village, well, it takes more like a small country, to put together a mission like Solar Probe. And so if we run the next movie, if you just watch the United States, all the states that had a major hardware role are being turned brown. And it's amazing just how much of the US really had a major role. And of course, our international partners too, with whom we would not have been able to do this mission. And so you've heard everybody say what a wonderful team this Solar Probe team is. From the people that have done our launch vehicle to all of our wonderful instrument providers, to of course the team that I love, that is the Parker Solar Probe team at the Johns Hopkins Applied Physics Lab. And so a lot of you in here have given up a lot of time with your loved ones because we've spent a lot of time working on this mission. And so I thought I'd just let you see your loved ones, because you probably haven't seen them for a while. If we go to the next slide. There you go. Do you recognize those faces? All right, so I know there's not so many people in here because a lot of them are working, but if you worked on the Parker Solar Probe mission, and I know all of my PIs are in here, so please stand up and be recognized. Come on, PIs, I can see you. Very much. So I think that is my get off the stage slide, and so I will say thank you very much.